the product model in CDM. And I'm going to go through this presentation. So I'm going to give you a little bit of background of why we are doing this. So the CDM has been developed for the past 8 years, and there have been several major versions. And the number of products that have been supported has increased significantly, especially during the last 3 years. And so there have been a lot of products being added. There have been new business events being added to the model. And while most of this has been successful, there have been some issues with the implementation. So there were a number of issues that accumulated in GitHub. And in certain cases, the model was just not optimal and was breaking the design principles of CDM. So last year, a task force which was endorsed by the steering working group was formed to accelerate the design and implementation of the refactoring of the model with a target of CDM 6.0, which has just been released in the past few weeks. And this task force, this asset refactoring task force, proposed some refactoring on different key areas such as product, observable, trades, assets, and general improvements to the models to address shortcomings and limitations in that were accumulating. In terms of why we initiated this refactoring exercise, essentially we wanted to make sure that CDM would be able to represent all types of financial transactions, products, and events in a consistent model that supports all markets and activities, and to resolve the years of inconsistent representations and data formats. So that's a little bit of background on how the work came about. In terms of what the areas of focus, so we wanted to take a look at the product qualification. So we wanted to address the inability to identify some financial instruments using the product qualification rules, because there are trades or insurance-specific terms and conditions which were not modeled in economic terms. So another area was the index. So we wanted to rationalize the current multiple ways to model an index to improve consistency and maintain the composable design objective of CDM and of reusing components to create more complex objects. Another area was the observable feature, and we wanted to address the inconsistent use of and barriers to extensions and reuse for more complex financial instruments, such as a basket and FX. And lastly, we wanted to remodel the price quantity to better enable the targeting of quantity change events. So that's at a high level. So this slide just shows a bit of what I was just explaining. So some areas of focus: assets, products, settlement, observable. So this is just a sample slide of the different phases that were implemented throughout 2024. So I won't go through any of the details here, but what I wanted to show you is the current model. It's the model in CDM5. So you may recognize, for those of you who have been using CDM5, you may recognize the structure. So here we were just representing a trade with a tradable product and all its components. So this model is no longer valid in the latest version of CDM, so version 6.0, which has just become a production version. So I won't go through the details of this. I just wanted to mention that this model is no longer valid in 6.0. And if you've been using it, you will need to make some upgrades to be able to leverage the benefits of CDM 6.0. Now, this is a slide that shows some areas of change that happened to the model in CDM 6. And we'll actually go through the different call-out boxes to highlight some of the changes that have happened. So here we actually start with the trade, and we're taking a look at the trade structure. So starting from the left, so we now have the product and the trade lot at the same level. We've hidden what was called the tradable product. So it's no longer like visible in an instance document. And we've also refactored the identifiers for our products and assets. There was the introduction of a non-transferable product in the trade. And there was a number of refactoring in the payouts. So we refactored the underliers on all the payouts, and we introduced new underliers as well. We refactored the observable structure as mentioned, as well as the basket and index structure. There were some changes to the price quantity. And there was a refactoring of the forward payout and other payouts as well, such as forward payout, asset payout was refactored. There was the introduction. There is the introduction of a new settlement payout, and also we've made some improvements to the price quantity. So we improved the model, as well as made some modeling changes to better support FX trades. On the far right, so we introduced a new asset structure with associated types. So we have an asset base, and we have a new refactoring of remodeling of the cash structure. So that's at the high level. What the changes. So there are many more changes that are not listed here. There are some documentation that task force has created that explains the extent of the changes, or all the changes that have been made. So I wanted to spend a little bit of time on the new CDM, on the new product model in CDM. And this is actually the model that I'm showing on the screen. So you can appreciate how simple and straightforward it is. And with that said, I wanted to maybe spend a little bit more time on this, right? So this diagram looks a little dense, and we're not really sure how to tackle this. So I think the best way would be to start more simply. And to do that, I'm going to start with a simple diagram, which is the concept of a trade that is negotiated between two parties. And the two parties agree to trade a product. So whether it be an OTC product or listed or cash, right? And often there's an asset associated to a product, an underlying asset. And an asset is defined as something that is owned by one party and that is transferable from one party to another. So we've gone from this to this. So now let's try to build up and understand how to come to the CDM6 product model. So the next part that we're going to look at is the asset structure. So as I mentioned, the asset structure is a new structure in CDM6. And essentially this is the structure. So we have on the left corner, so we have the representation of the asset structure in Rosetta using the Rosetta UI, and on the right we have an abstract representation of the model. So we're going to delve a little bit into this so that you can understand what it contains. So the asset data type is represented as a choice of several underlying data types, which means that one and only one of those data types must be used. And actually, I'm going to try to switch a little bit to the model so that you can take a look at the live model. So in using the pin icon, I'm going to type asset and I'm going to navigate to it. So here the asset is a choice type, meaning that only one of the attributes, so cash, commodity, digital asset, and instrument must be used. And each one of these data types actually extend another common base, which is the asset base. For example, if we take a look at cash, and we go to the definition of cash, we see that cash extends asset base, and the asset base was actually defined right underneath the asset. So we have the asset base. So here the asset base contains attributes that are common to the four attributes of the asset. So we have an identifier for an asset identifier. We have the ability to specify the taxonomy for the asset. We can specify whether the asset is exchange listed, the exchange itself, or the related exchange. So this design allows all the attributes under asset to inherit the attributes from asset base. Let's see. I'm going to maybe switch to the graphical definition, to the graphical view. I'm going to take a look at the asset sort of the graphical way. So here we see the structure. We see that there's an instrument structure. So an instrument is an asset that is issued by one party to one or more others. So an instrument is also a choice data type. So we saw that asset was a choice data type, and the instrument is a choice as well. And before I take a look at the instrument, I'm going to maybe spend a little bit of time on the four different components of the asset. So the cash is an asset that consists solely of a monetary holding in a currency. And the only attribute of that is the only data type is the identifier populated with the currency code. And you can specify the currency for the cash. The commodity is an asset comprised of raw or refined materials or agricultural products such as gold or oil. And the applicable identifiers are the definitions for reference benchmarks. And you can also, if no benchmark exists, the characteristics of a commodity asset can be more fully identified using a commodity product definition. The digital asset is an asset that exists only in digital form, such as Bitcoin or Ethereum, and excludes the digital representation of other assets. And lastly, we have that instrument, which can be issued, which is a particular type of asset that is issued by one party to other parties, one or more parties, and that's also a data choice. So a data type. And let's take a look at the instrument a little bit. So the instrument is further broken into a choice construct with a listed derivative. So that's for a securitized derivative or another asset that is created by an exchange. We have a loan as well, an asset that represents a loan or borrowed obligation. And we can have a security as well, which is an asset that is issued by a party to be held or transferred to others. So that's at the high level. Let me go back to the structure here and see. I think that's all I wanted to cover. So here in the abstract representation, we have actually the listed derivative, security, and loan that extend another type, which is base type, which is instrument base, and which extends the asset base as well. And you can let me take a look quickly that in the model. So if we were to take a look at the listed derivative structure, we would see that it indeed extends an instrument base, and instrument base extends the asset base as well. So when you take a look at this diagram, it essentially reflects the model in the CDM model. Let's move on more rapidly into other structures. So we have the index, and an index is a data type to record information about prices, rates, and valuations. And the index data type extends the index base data type, which in turn extends the asset base. So an example of an index would include like equity market indices, as well as indices on interest rate, FX rates, inflation, and credit insurance. So now let's move on to, and I should mention some of the types of indices that are stored and are displayed here. So you can have credit index, equity, interest rate index, or other indices. Let's move on to another part of the diagram, and we're going to take a look at observable. So you see that we've little by little built part of that giant obscure diagram that I was showing at the beginning, right? So we discussed assets, instruments, indices, and now we're going to connect them together using an observable. So in addition to assets, there are variables which can be observed in the market and which can directly influence the outcome of financial products. In the CDM, the observed value represents the price of an observable. So the observable data type specifies the reference object whose price is to be observed. So it could be like an underlying asset, can be held or transferred, or it could be an index. So you can observe an asset or an index. Let's move on to the next slide. So now we're going to discuss a little bit about trade lot, about the trade structure. So this is a snippet of the trade representation in CDM. So you see that like a lot of the attributes are not shown. We can see the product here, but here we wanted to focus on a branch that introduces trade lot, price quantity, and observable, which we just discussed. So within the trade, we have the concept of a trade lot, which specifies the prices and quantities of one or more trades, where the same product could be traded multiple times with the same counterparty, but in different lots. And then we have, so that's the trade lot. You can think of it as an equity trade lot. So that's where the term came from. We have within the trade lot, you can have a lot identifier, and you can have the price quantity as well. Let me check the time. And the price and quantity attributes of a trade or of a leg of a trade in case of a composite products are part of a data type called a price quantity. And within the price quantity, you have a number of attributes such as the effective date, the observable, which we discussed in the previous slide, the price, as well as the quantity as well. So this is the structure. And let's move on to the next structure. So here we're moving to another part of the diagram. So here we're going to take a look at the trade structure. So so here in the center of the diagram. Yeah, go ahead.
No, I just wanted to ask a quick question. Sorry.
Sure.
Yep. Lyteck, the questions around the trade lot and the trade lot and the application of it to interest rates and other non-equity product types. So I think if you could just show the way you express the price and quantity of an interest rate swap, that would help. So we can, maybe to foretell the answer, we can set the price as being a rate or a fee or a cash amount or anything like that. That's possible under the price type. And then the trade lot is merely a container to separate out many different quantity and price pairs, if you will. Does that make sense? Oh yeah. So if we could, maybe Lyteck, if you just show the price type and the depth of and granularity that is achievable for price type, that will probably help.
Yes. So let me back to here.
Is completely expressed using the price type precision unit of. So that's brilliant. Thank you.
Thank you. I'm looking at the time, and I should be picking up the pace on the slides, but I think this should go much faster, hopefully. So the trade. This is a new structure. So trades are composed using a new structure called a non-transferable product, which has economic terms made up of one or more payouts. And I've been struggling with the new font from Microsoft called Aptos, which messes up all the fonts here. But a trade is composed non-transferable product, which has economic terms and which are made up of one or more payouts. So this is the representation here. So you have a payout structure. You can have different types of payouts. The economic term structure represents the full set of features associated with a product, and the definition of a tradable product is a financial product that is ready to be traded. And by associating a specific price and quantity to the product definition, plus optional conditions, you would have the tradable product. And then the payout essentially represents, like it existed in CDM 5, but it essentially represents the set of future cash flows in the form of specific payout data types. So you can have a payout structure for interest rate. You can have for commodity, for settlement, for assets and whatnot. And these all extend a payout base. Let me maybe spend a little bit of time on I guess the concept of composability. So here the idea is that in CDM you don't really have a definition of a dedicated definition for an interest rate or an FX swap. So all these products are specified using a combination of one or more payouts. And that's what we'll spend a little bit of time here in this slide, which shows how some TC products can be composed of different payouts. So here, a credit default swap can be created by using credit default payout and an interest rate payout for the payment. Another product, the interest rate swap, is the combination of two interest rate payout. So you would specify two interest rate payout. And the commodity option, similarly, you would use commodity payout should mention that most of these payouts contain an underlier feature that allows to represent the underlying instrument of the derivative. There's an example here in the option payout. You can reference an underlier. CDM contains, covers other financial products, so repo agreements, securities lending, ETDs are covered. And this shows the payouts that you would need so for repo agreements, an interest rate payout is needed to represent a cash loan, and an asset payout is needed to specify the collateral. There's a documentation for each of these in the online documentation, so you can take a look at this. So here, I just wanted to show you the asset payout, an underlier that references an instrument. This is a summary of the products that are covered in CDM. OTC derivatives, securities lending, repurchase agreements. So you have all of these, and the fact that CDM, that the concept, that the principle in CDM of composability, which means that you can create new product from payouts, would allow you to maybe cover more exotic products that are not listed here. So I'll just skip quickly on that one. And here we discuss payouts, and we wanted to spend a little bit of time talking about qualifying functions. And the concept of qualifying functions is not new in CDM6. But as you can imagine, with all the changes, all the refactoring that happened to the trades and to the products and introduction of assets, right? So there were a lot of changes that were made. So not only the model change, but all the qualifying functions had to be refactored to take into account those new enhancements to the model. So the examples had to be updated as well, the test packs, and as well as the mappings, such as mappings from FPML to the new CDM. So here the idea is that if all the products are a combination of payouts, how can you tell whether a combination of payouts is an interest rate or fixed float, or whether it's an FX, right? So in CDM there are qualifying functions which is code that allows you to test the economic terms, so the structure that contains the list of payouts, and essentially determine whether, in this case, this is an interest rate fixed float or not. So here, this example shows that this function actually calls other functions until the result is determined of whether or not this is the product that is being fed into this function is a fixed float or not. I'll just move on quickly. I'll just show taking a look at the time. So here we're presenting the trade structure, and essentially in one of the structure, it was mentioned that trades are composed using a non-transferable product, which is this box here, which has economic terms. So I just wanted to refresh your memory here. So a non-transferable product with economic terms of and payouts. So now we'll go back to the structure. So we have a trade, we have a non-transferable product, and indeed we have economic terms and payouts. So and here in terms of differences between 5 and 6, we do the increased use of inheritance essentially allowed us to reduce the number of levels in the model, particularly in the JSON projection. Now trades. So here we have a product, And the product can either be a non-transferable product or a transferable product. So let us spend a little bit of time on this. So essentially a transferable product. So maybe let's start with the non-transferable product that is highlighted. So a non-transferable product describes a commitment between two parties to one or more transfers of assets in the future. So, and because an asset is a basic type of financial product, the asset data type only needs to provide limited information about that product. Essentially, it allows to identify the product using publicly available identifiers. A transferable product is a type of product which allows to specify the economic terms of an asset. It can be used as the underlier of a basic payout that describes the buying and selling of an asset. So by contrast, we have a transferable product, so the path at the bottom, which associates an asset itself transferable with the economic terms describing that asset. So a transferable product can be held by a single party who can in turn transfer it to another. Some financial products can consist of bilateral agreements between two parties. As such, they cannot be freely transferred by one of the parties to a third party, at least not without the consent of that party. And such product is usually materialized by a financial contract between those parties and can also be referred to as a contractual product. So let's go back to the diagram. So we discussed
just quickly to reiterate that transferable versus non-transferable concept. A transferable product might be thought of as something that's fungible, like a share or a commodity or a bond or something that you can buy and sell. And a non-transferable product is something that's negotiated into a standalone contract, like an OTC derivative. Is that a rough analogy to those definitions?
Yes, thanks for further clarifying that. Yes, that's a better explanation than I probably provided there.
No, it's all good. All good.
So now if we go back to our diagram, we have a trade that is a non-transferable product, and we established that the product can be either a transferable product or a non-transferable product. And for that, I'll just go back quickly to the model to make sure we cover that at least. So that's in the structure. And if we go back to the product and move and take a look at the code itself, that the product is a choice type, and one of the two needs to be chosen. So, and I think the next few slides cover, I guess, what I already mentioned. So this is a transferable product, which is a type of product which enables the specification of the economic terms of an asset. And we also have here, this slide just shows that, just covers again that a product can be either of the two here. I'll just keep that through quickly. This is the same showing both non-transferable and transferable side by side. I'll skip that through quickly. And here we now have the entire model that we had seen at the beginning. So with all the components. And here this just covers the economic terms and the payout, so essentially both the economic terms and the payout define the characteristics of a product. And here we actually have an example of an FX trade, and it's using the framework that we just discussed. So here, an FX trade is using a settlement payout. So here we have the settlement payout, and which has an underlier of a cash asset. So this is how it would be represented. So it came from this complex structure, which contains all the possibilities to just using the settlement payout with a cash asset. And that's why we are reduced to this picture here. So here we have the concept of an underlier. So essentially it can be cash or security or any of the options that are available. And here is another example of an FX spot and forwards. And here essentially we have the specifications for the trade, and we also have a sort of the hierarchy of the trade. And in green, it's essentially the structures that have been significantly impacted by or introduced by the CDM6. And on the right, we have some sample values for those structures. So the settlement payout was introduced, the underlier, the observable was impacted, and there was a redefinition of observable and cash as well. So here, in terms of structure, what we need to look at is we have the trade. Inside the trade, we have a product. We have economic terms. Within economic terms, we have a payout. And within the payout, we selected for FX, we're choosing a settlement settlement payout with all the payer receiver, the price quantity, settlement terms. And then separately, we have a trade lot, which specifies the price quantity for this product. Now, any questions on this? Ian, anything to add on?
No, I think that makes sense. The observable in the price quantity and the observable in the underlier, there's a way of triangulating them as well, isn't there, in the model? I think there's some helper codes to validate such things. But no, is there any questions from the audience? Me wave? No?
Maybe with the
Lyteck, sorry, I just wanted, on the previous slide, what was the green highlighting? Sorry if I missed that in your explanation.
These are structures that have been significantly impacted by the asset refactoring that has been completed in CDM6.
Right, against the 5 to 6 refactoring. Thank you.
We have more examples of this. So this was just extracted from a deck that contained examples of how an interest rate is specified, like using 2 interest rate payouts. So this is an example. So we have an example of, let me show this one, of an FX option. So we created sample slides for different products to help with firms with their implementation or get started. So with that said, we have a few minutes left, and we wanted maybe to introduce a little bit of interactivity. And we wanted to ask you to think about how you would represent an equity swap in CDM6 based on what you've learned so far. So I don't know, you may have your laptops available, or you may have access to Rosette, but we've also included the economic term structure with the different types of payouts available. So what you could be doing, you could also be in looking at the different payouts in Rosetta, like the inside of each, to see which ones could be used for an equity swap.
So, anyone want to put their hands up and guess how you do that? No one's brave enough. The funding leg on the equity swap. So, an equity swap is when I'm getting equity performance on one leg, but I have to pay for that by paying LIBOR. You don't pay LIBOR anymore, Euribor, or something like that on the other leg, on the funding leg. So it's a swap. It has two payouts. Yeah. So it's a performance payout and the interest rate payout. Yeah. It could be fixed price, I guess. You could, if it was one bullet payment, I guess. But if it's a more complex payment structure with different calculation periods, you'd use the interest rate payout. So there's the performance payout. And you can set the terms and stuff like that. An underlier is an underlier under the model. So theoretically, you could probably get even more complex. But how would you deal with things like payoff is in different currency to the funding currency? So for when there's two different legs, you can have, so the price quantities can be separate. So you can have a price quantity for each leg. And that means you can keep things separate, if that makes sense. And then it's the observable which links them together. So that's why you see observable with the fixed, with the price quantity. It seems like it's duplicative, but it's not actually. It's when you might have lots of different legs. Lyteck, did you have any more puzzles for the group or any closing remarks?
No, I do. I just wanted to maybe check to see if there's a qualifying function for an equity swap, because that's another. Sorry, well, what's the? Hang on. What's the syntax again? Sorry, bear with me for a second. I'm just trying to get back to that slide that had. Okay, so the qualified. So there are qualifying functions. So we'll just quickly go take a look at whether we can find the qualifying function for qualify equity.
There you go.
Okay, so we'll take that one.
Parameter return. Yeah. It's a funny name, parameter return, which I never understood.
Yeah, I'll just pick that function, which is equity option. So essentially, that's a function that qualifies whether the product that is being fed as input is an equity option, right? So, and this is the code here, the output. So, and let's see take a look at this function, qualify asset class equity. No. But essentially, what this does is it takes a look inside the economic terms, and it evaluates whether an option payout is, and a basket within option payout is available. And based on like multiple conditions, it would return true or false. So this is not exactly the equity swap, right? But this is an example for the equity option. So you can also take a look at inspect the qualifying function to determine like that other experts have developed, to see what you need to use in terms of payout too. So that could help you as well. There's a slide. There's a last slide I wanted to just recap what we've looked at. So there have been extensive changes in CDM 6 in terms of the refactoring of products, introduction of assets, payouts, And the goal really was to close or to address a number of shortcomings and issues that have accumulated over time, and to enable the representation of all types of financial transactions and products more consistently and across all markets. So that's the idea. So we hope that we're sure that the CDM6 model is more robust and will allow us to move forward and to grow in like the different markets, or to add additional products more easily. So an important resource is the online documentation. So there's an extensive description of the product model and the event model. So the product models, I've intentionally used like the DAG from the online documentation, so that you would be familiar with like the framework and that you can get started, continue on your journey more easily. So take a look at the online documentation. And yes, so if you are interested in the rationale behind some of the changes that were made by the Asset Refactoring Task Force, you can take a look at the GitHub repository, where all the minutes and the work in progress designs are kept. So CDM6 was just released. Please take a look. You can provide the feedback to FINOS through the channels. Yeah. So with that said, thank you very much for having me. If there are no more questions, I'll turn it back over to Ian.
Thanks, Lyteck. Any questions? Sorry, well, hang on. Let's get the microphone so we do this properly. And all recorded. Yeah.
Hi, this is Rachna from Bank of America. Great presentation, Lyteck. Yeah. I think it was very useful to see you have a function where you can give the economic terms as the input and get your product name spit it out. Is there a reverse function where I can say, hey, you know what? I want to build equity swap. Can you give me back the mandatory economic terms that I must enter to compose the product? Yeah.
No. And this goes back to the discussion earlier about identifiers and taxonomies. But so you'd have to pick what labeling mechanism, what taxonomy you're choosing to identify the product as. And you could say, yes, I want to get an equity swap per this taxonomy, but then it gets very difficult to manage. But the idea of having pre-collected templates to build trades and products has been raised before, but I'm not convinced that's a good path to have templating in that way. But having a sort of a quick way to manage and use the CDM, yeah, maybe. But that's something we can discuss, I think, in the future. But it doesn't exist. It's for labeling after you've constructed the product.
I mean, the second thing is, if we have to really get started with this, yeah, to compose all the products, even if I have to play with it.
Yeah.
We already have so many trades.
Yeah.
Today, we do have it in the FPML format, which is recognizable by everyone. Is there a code snippet or something where I can take an FPML, convert it into CDM6, and get going to play with this?
So the translation of external data like FPML data into CDM is something that is available and there's a new version of the translation tools that's effectively converting from FPML using Rune into CDM. That's something that's being worked on imminently. And if you want to know when it's going to be delivered, ask that guy from Cork there, because he's working at Regnosis and they're delivering them.
Because that's the way it will allow us to quickly load multiple products, commodities, equities, interest rate, and see how this is.
Yeah, no, it's part of the Rune project, which is also open source at FINOS. And the guys at Regnosis are working on a component or a tool to make that translation easier. So there's different ways, to get your data from FPML and FPML trade into CDM. And then the idea of having a quick, like the object builder is a way to see where the steps you need to take. Remember, Vernon showed the object builder for collateral specifications. You can use it for trades as well, and you could step through the process and you could use that as well. But the idea of having template, you put in interest rate swap and it tells you what to fill out. Yeah, I could see it at a very high level, but it gets really complex really fast. And one person's interest rate swap is not another person. And then we get into this idea of naming conventions and stuff like that. So that's why it's not there. But Oleg.
The CDM 6 support all the asset types, not only equity as well,
So
because it
yeah,
their financial
So-
instruments.
so now with version 6, I guess it's clearer, but the coverage is obviously all the derivatives across commodities, equities. Where's that picture? So here we go. So obviously the interest rate derivatives, credit derivatives, equity derivatives, options, securities lending, and repo, but also the securities on their own and the equities, underliers, that sort of stuff is also, you can also present trades in them. So yeah, it's a pretty full, and loans as well. So like it's pretty much as much of capital markets as we can think of, and robustly tested. And this is the way I think of it. And again, these labels are nebulous to your point. We know we have all the components there. People need to test it. But for the derivatives, to get the reporting working that we talked about this morning, if you want to report for a CFTC or a MIR or the Japanese reporting, all those things, we have to cover all the products that are reportable in those jurisdictions. And that's all the derivatives trades. So we know for derivatives, it's in production, it must work. If JP Morgan has it working, if BNP Paribas has it working, it's not only partially working. So yeah.
Thank you.
Okay. Thanks, Alec. Okay. Right. Another question.
Only because of something you mentioned.
Okay.
And sorry, I don't know his name. The gentleman from Veganosis.
Oscar.
Was that the FPML mapping stuff that's becoming open source? I've heard.
I'm putting him on the spot because it's the translate 2.0. We have to give it 0.0. Everything has to be semantically versioned. Translate 2.0 is imminent. March.
Thanks.
I
I heard it was January. But obviously January's gone now, right?
just Austin at the back.
So my question is, if you have your own proprietary message, and if you wanted to create a CDM
Yep.
out of it, so at this point, since we don't have like a template,
Yep.
would it be a good option to chase one of the synonyms, say take one of the FPML synonyms
Yeah.
that are already mapped a particular asset class,
Yes.
and go through that? Would that be the best option at the moment?
Yes. So you can extend, you can obviously, so all the synonyms or all the mapping stuff for translators is an extension of the model into your own. So you effectively build your own model, which is extending the CDM, and you're creating your own, you put your own data model for your trade, whatever it is, and you map it in. And then every time the CDM gets updated, you've coherent and the bindings are still there. So the CDM does, or in Rosetta, for example, there's mappings for FPML 512, right? And there's loads of examples there. And what we did sometimes was we'd ask people to send us XML data from their own systems. So, for example, we're in Barclays house. So Barclays have BCML, which is a internal XML messaging standard that they use, but it looks a lot like FPML, and it's obviously very. So what we would do sometimes is we'd get the FPML 512 message, like one from the examples. We'd delete all the center of it and copy and paste the XML text in. It would map in, and you'd find that most of the differences are in the headers and the footers and a few different tags. That is a hack that works. So that would be something I would look at. Yeah.
Just one more thing on the back of this.
Yeah.
We have members who want to add certain identifiers, or rather certain enhance the CDM model.
Yep.
And
Enhance is being used liberally there, but yeah.
more fields. So because it's already possible to some form in FPML where you can create your own identifier.
Yep.
So then the route would definitely be is you create those mappings for your additional fields from FPML to CDM.
Yeah. Yes. So there's plenty of placeholders in the CDM for identifiers. Lyteck's doing a sterling work showing the mappings. You have that trade identifier object, which can have multiple trade identifiers. You can have loads of blocks of identifiers. So the CDM caters for that. Question is, what's the value of all those identifiers? But being able to house them and pass them through the CDM is not a problem. Extending it and creating new data types in the model for the sake of it and giving it a fancy name like risk system A identifier is not good practice. So it'll fit into the identifier. The identifier type is really well defined with a source and a value, and all you really need to make it work.